So it's my pleasure to invite Nele on stage. Nele is the coordinator of the streamSAVE project, and she works as an expert on energy policy and evaluation at the Belgian Research Institute Vito Energyville, having 15 years of experience on providing support to EU countries. Nele, the floor is yours.
Good afternoon, everyone. It is good to see the high interest in the subject that streamSAVE is dealing with. I will start sharing my screen first, so that I can start giving you an introduction to the project, so you know in broad terms what we are doing. streamSAVE is a consortium of 12 partners, and we started last year in September with the project. Vito is coordinating the project, and multiple types of organizations are involved, reflecting the needs that we address, and also the type of stakeholders involved. So research and more policy-oriented institutions, energy agencies, and then institutions more closer to the market and the technologies itself. As you can see, we are spread in multiple countries across Europe. In broad terms, or what are we mainly aiming for? We build capacity among public authorities, so to member states, on the Energy Efficiency Directive, more specifically on Article 3, so national target setting, and Article 7, or energy savings obligations, also in the multiple countries. I will tell you in the next slides a bit more on how we do that, but what I want to already emphasize is that the project is centered around multiple priority actions, 10 in total, of which 5 will be dealt with at the beginning of the project, so the first half of the project. And what is a priority action? That are technical energy saving actions that still have a high energy saving potential within member states, and that are considered as a priority issue by policy officers and other stakeholders. So we want to be as close as possible to the needs that countries have. And by building the capacity, we want to realize additional savings in the multiple member states in relation to these articles. More specifically, we aim to streamline calculation methodologies for these 10 priority actions, to make or to support a comparable progress reporting on energy efficiency, while of course we do realize that there are strong differences in member states because of differences in data availability, also specific situations in the energy sector, etc. So to streamline these methodologies, we build up a guidance on standardized saving methodologies, and that is what Elisabeth will present you in one of the upcoming presentations. Next to building a guidance, we also organize dialogues for technology group experts, for policy officers and other market actors, where they can discuss their experiences with methodologies, and where they can learn more in depth on the guidance. These dialogues, maybe some of you already attended some of these in the previous year. These dialogues or web meetings are centered or organized for each specific priority action. What we also do is providing technical assistance, so one-on-one support to the 10 partner member states, where we bring the guidance into practice. So we can learn more on how, so we can collect more lessons learned on how it can be as useful and as practical as possible, and put all these lessons learned next to the guidance and other relevant deliverables and outcomes that we learned during the project on our platform. It is not just a platform that we want to create where you can find all relevant information and where you can try our methodologies, but it's also a place where you can ask questions to the consortium, and where experts or you can contact experts in the same field, so you can share experiences. This picture summarizes what I just told you. We have multiple, so in the knowledge facility, we develop our guidance, then we have our dialogues, and in the capacity support facility, we provide support in the 10 partner countries and bring that together in the platform. But what I mainly want to show in this slide is that that's what you see on top of this graph. The first row of priority actions we deal with in the first half of the project, namely heat recovery, building automation and control systems, refrigeration, electric vehicles, and lighting systems. But Elisabeth will tell more to you on how to interpret these priority actions and also explain you more on the methodologies. But these are our first round of priority actions we deal with. From when we are halfway the project, which means from March of next year onwards, we will deal with the next series of priority actions. And at the moment we are defining these. Based on earlier consultations, we learned that the following 7 actions are of interest of our stakeholders. But we are currently running an online survey where we want to learn more on what actions are they most interested in and what is the scope of these actions. As some of these are still quite broadly formulated, such as renewables, heating and cooling, or providing feedback, etc. But we want to learn more what specific aspects is of most interest of our stakeholders and of the policy officers. So we welcome your feedback as well. I will put also the link into the chat so you can share what actions you consider important to deal with in streamSAVE. So in short, what do we stand for? Streamlining energy saving methodologies, and not only the methods, but also indicative values and information on costs. We focus on priority actions. We want to be as close as possible to the needs of our stakeholders and make sure that there is a good sharing of experiences. And if you hear while during this webinar or after this introduction, I know another initiative or project that can be of added value to streamSAVE, please do not hesitate to contact us and let us know. You can find the contact details in this slide. And if you want to be kept up to date on the project, you can also subscribe to the newsletter via the website. That's it, my short introduction on streamSAVE. And before going to the next presenters, I first also want to thank, of course, the presenters today of willing to share their views on standardized saving methodologies. So thank you.
Okay, thanks a lot, Nele. This was a very clear and concise overview of the project and its goals. Thanks, and also thanks for keeping it within the time. And I'm echoing your call to the audience to please indeed enter into contact with the streamSAVE consortium if you have other projects, project outcomes to share with us. So you have the contacts there in the slides. Our next speaker then is Anne-Katherina Weidenbach from the European Commission. Anne is policy officer at DG ENER, Unit B2 on energy efficiency, dealing amongst many other things, I guess, with the recast of the Energy Efficiency Directive. Anne, may I invite you on stage? And if all go well, then Nele will start sharing your presentation.
Thanks a lot. Thanks a lot for the introduction and also for inviting us, or in this case me, to join the conference. I'm really curious also to see later on the findings of the guidance, because I really think that this is one of the key works that can contribute to the success of the Energy Efficiency Directive. And just as a general remark, and I think it's not new for you, but I really want to make that point again. It's a very important topic to ensure that all policies, be it at EU level or national level, are reliable. It's a question how can we show that public money, for example, that it's spent also to stakeholders, but also for industries who have to implement some of the measures, that it really pays off to take efforts, to make efforts, and to implement energy efficiency improvement measures. And in this regard, it's not only about a simple methodology, but also, let's say, one of the key pillars for showing that energy efficiency policy is really contributing to decarbonization also, and will help to fight also climate change. Maybe the first slide as a general remark. Yes, thanks a lot. No, I think that's the third slide. Yes, exactly. Thank you. So I'm starting from the Energy Efficiency Directive as it stands now. For the calculation methodologies, we have currently 4 options that member states might wish to choose. So either they can use deemed savings, metered savings, scaled savings, or surveyed savings. And 2 of them, 2 of the options could be used or are used as standardized energy savings calculation methodologies. And in this regard, I prepared also the next slide, please, where I tried to show from our experience where these methods are usually used. So the deemed savings are usually used for projects with large number of similar actions. So that means that the actions can be described in a standardized way. Whereas the scale savings are more often used for an intermediate number of actions or which are partly similar or partly specific. And the metered savings, where we have, let's say, large actions or projects, but those actions or projects are very specific. And there it's already the point that metered savings makes sense only where the amount of energy savings is high enough that it can be distinguished from energy savings achieved by a specific policy measure, for example, or where the changes are a result of other actions. Deemed savings could be difficult or at least not that easy to implement, also because of the costs that occur. And for the scale savings, collecting energy consumption could also be difficult or expensive, but some specific data can be collected or at least at reasonable costs. For the next slide, please. Also there, I don't want it to call it advantage and disadvantages, but let's say the advantages first, and then there are some limitations, which doesn't mean that the calculation methodology doesn't make sense at all. It's just to highlight also afterwards maybe to consider if the calculation methodology chosen is really fit for the concrete policy measure or project or action. So the advantages of deemed savings, clearly you have low monitoring costs or and also visibility to market actors. So values are available beforehand and can be used for those policy measures, for example, for energy efficiency obligation schemes, but also voluntary agreements, so for a large scale of policy measures. Nevertheless, it requires actions, as I said also on the first slide, that can be described and documented in a standardized way. And it requires also member states to have reliable data at hand. And from our experiences, this is not always the case. And it risks not to reflect individual cases. And also in the end, there might be possible gaps between the average values used and the deemed savings that are reported under the actions. Regarding the scale savings, also there clearly the advantage is that it could be a reasonable compromise between reliability, but also the need to monitor and verify the energy savings, but also the monitoring and verification costs. As it's a quite flexible way of calculating, it can address specific actions. And maybe this is also interesting for project planning. It can give a good overview to project planners regarding the investment needs. But there also, it might require upfront, but also later on, high administrative responsibilities and costs. It depends, of course, on the number of actions, but also the data collection could lead to, let's say, an increased cost compared to other calculation methodologies. And there it reads simple, but of course, experts are needed, training of experts is needed, guidelines are needed to ensure that the scale savings methodology is compliant and reliable with what is required, for example, under the EED. The metered savings, of course, there for some areas where you can also consider like the smart meters in households, it results in that, for example, consumers are in the position to know their actual consumption, but also the actual energy savings. It can also be useful for planning of projects. It's what I already said for the scale savings. But costs might be, of course, be disproportionate if you have to have meters at the relevant points of a project, and the data needs might go beyond the energy consumption. So with metered savings, you also need to take into account other factors, for example, weather conditions, geographical conditions, or production volumes. And this is also one important point with the requirements for data protection and confidentiality. This, of course, needs to be ensured beforehand, but also how data is processed afterwards. This could also lead to higher administrative costs in terms of metered savings. Next slide, please. Thank you. In here, I would like to make the point that from our perspective and experience, also from feedback from contractors we receive, that the documentation of deemed savings is really key. It's also provided in the Energy Efficiency Directive of the current one in Annex 5, paragraph 3.3c, where it says that member states have to show that energy savings that are achieved have to be presented and determined in a transparent manner. But also you can find in Annex 5.5 the requirement for the notification methodology. There also the calculation methodology needs to be shown. But here, to comply with these reporting obligations, it's also key that the use of the deemed savings is documented in a proper way, and only if documentation is carried out in a sound and reliable way, then it can be really reliable and useful data reported. But this will also require that it's reviewed and, if needed, updated on a regular basis. Next slide, please. So briefly on this slide, I will come to the EED revision and the Commission proposal for a revision. Based on what the climate target plan required, we also try to provide an amendment proposal on the EED to unlock remaining energy savings potential. Next slide, please. This is just showing to you the main elements of the Energy Efficiency Directive proposal. And I would like to focus on the strengthened energy savings obligation in end use. Next slide, please. Here, what remained? Yeah, what we changed is the energy savings rate. So as from 1st of January 2024, the idea is to require all member states to achieve 1.5% new annual energy savings each year. But we retain the flexibility for member states regarding the choice of policy measures, and also regarding the sectors to target. Next slide, please. What we also retained is the approach for member states to choose among the 4 calculation methods. So Annex 5.1 remained untouched. And basically also the requirements for materiality and additionality remain the same. In a way, so member states shall also demonstrate, and which is already the case today, but we clarified it in a way that member states need to demonstrate that the policy measure has been implemented for the purpose of the energy savings obligation, and also that member states shall provide evidence that the energy savings are caused by a policy measure. And that's why I mentioned it. So clearly materiality requirement is clearly linked to a proper choice of the calculation methodology. The same also applies for the additionality criterion, especially with regard to some other proposals we have in the Energy Efficiency Directive recast. Next slide, please. Exactly, there I wanted to highlight that we have 3 amendments where member states, if the amendments are accepted by the co-legislators, of course, how member states will deal with the requirements to promote the installation of solar thermal technologies, and also the requirement that member states can count in general all energy savings, except those resulting from policy measures promoting or supporting the use of direct fossil fuel combustion technologies. And also the question how member states will decide to fulfill the additionality criterion or principle related to the EU ETS, because energy savings from the EU ETS must not be counted towards the energy savings obligation. So in a way they need to be distinguished from the calculation of the overall impacts of policy measures. And there also member states would need then to consider which calculation methodology would fit well. And also what could be discussed in future, as said, if these proposals would be expected, how member states would go for the calculation of energy savings that they need to achieve among vulnerable customers and people affected by energy poverty, and where applicable, people living in social housing. There is a new provision or amendment to the provision of Article 8 in Article 8 paragraph 3, where we propose to require member states to achieve a part of the cumulative savings among those vulnerable groups. And with that, I hope that it was useful and interesting for you. I hope the timing is more or less okay, and happy to answer your questions.
Okay, thanks a lot, Anne. This was a very nice overview, and I in particular like the comparison of the different advantages and limitations of each of the saving calculation methodologies, and also great to have seen an insight on the relevant amendment proposals in the EED new proposal. So thanks for this overview. I hope that you can stay with us for another few minutes, because we have first two more presentations, and we will dive into the questions and answers. So please stay with us. Okay, thanks. We have another expert in the EED now. Our next speaker, Elizabeth Buck from the Austrian Energy Agency, who has been working on the implementation of the EED in Austria, as well as on projects dealing with various aspects of the EED implementation, and also experience exchanges among member states. And as one of the streamSAVE consortium partners, the Austrian Energy Agency is responsible for the implementation of streamSAVE's work package 2, dealing with the calculation methodologies for energy costs and greenhouse gas savings. So Elizabeth, the floor is yours.
Thank you, and welcome from my side as well. I will share my screen, at least if my browser lets me. So much for preparing a test for testing up front and then still having problems with this. Now it's working. Okay. So I hope my screen is shared now.
Yes, we can see your screen there.
Thank you, Didot, for the introduction. Okay, great. I will use the next few minutes to present to you one of the major reports that the project has by now already published. Publication of our guidance on standardized saving methodologies was in September of this year. And the guidance is focusing on energy, CO2 savings and costs. So maybe a short introduction on what you will find in there. The first chapters are rather focused on general aspects of the estimation of energy savings. So for example, what are the differences in savings calculation for Article 3 and Article 7 of EED? How to define a baseline that is in accordance with the Energy Efficiency Directive. What approaches are there for accumulating energy savings under Article 7 EED, and how to account for correction for behavioral effects. Additionally, we have information on how we set up the estimation of relevant costs connected to energy saving actions and the estimation of greenhouse gas savings. For now, as Nele has already presented, we have the first round of priority action featuring 5 different technology groups and have prepared 8 or newly developed 8 methodologies, 3 on heat recovery for on-site use in industry, 1 for on-site use in industry with feedback of excess heat into a process, then the on-site use of recovered heat in other applications, and then in case recovered heat is fed into a district heating grid. Another priority action focuses on building automation and control systems in residential and non-residential buildings, featuring different technologies like heating, cooling, ventilation, hot water, and lighting control systems. Then 1 methodology on energy efficient compression refrigeration units, so cooling. Then fuel switching to electric vehicles, and 2 methodologies in the area of road lighting systems, or basically 2 calculation approaches. For each methodology, we present a guidance on how to calculate the final energy savings for Article 7 EED, including indicative values based on statistical data as far as this was possible, because this will to some extent depend on the action itself. Then the calculation of the impact on energy consumption, so relevant to Article 3 EED, Then an overview of costs related to the action, featuring investment costs, variable operational costs, fixed operational costs, and revenues, featuring either really data on how high these costs might be or information on where you could find such information. And then at last, a calculation of greenhouse gas savings. Sorry, that was too fast. So I will now present you the 5 priority actions and what they are targeted at exactly. For heat recovery in industry, like already explained, there's feedback into the same process, then feedback to another on-site application, and feeding into a district heating grid. Of course, this is not a methodology that you would per se define as steam savings, because in industry as use cases are very, very different. This can be rather seen as a guidance, helping stakeholders to know what savings can be accounted for, and to identify what energy streams need to be considered and how to normalize measured data so everything is correctly reported when reporting savings. And of course, such measures will have a great impact on fuel reduction and also energy costs of industrial processes. Then for building automation and control systems, we do have a methodology prepared for heating, cooling, hot water, lighting, and ventilation of residential and non-residential buildings. Apart from preparing the methodology, our goal here was to increase the effective use of energy in these areas due to the automation, and also such systems help in the detection and diagnosis of inefficient operation. Also, apart from the energy topic, such systems can help increase comfort and convenience for building inhabitants or building users. Regarding industrial and commercial refrigeration, this is targeted at replacing old electrically operated compression refrigeration units, either water or air chilled, with more efficient equipment. So this is not about room conditioning, but rather really about cooling appliances. Therefore, the methodology is based on the seasonal performance ratio, so SEPR values. And objectives and benefits of such methodologies is first to have a common and uniform methodology to calculate savings achieved by such replacements. And as we did a stakeholder consultation on where problems lie within those priority actions, especially defining a baseline to compare the savings to was hard. So we tried to help with this in this methodology. Then we have one methodology on electric vehicles, so fuel switching between conventional and electric vehicles, which ensures saving due to the higher conversion efficiency. Also, this will have a high impact and hopefully an even higher impact regarding our climate goals in general, as more and more electricity is based on renewable energy resources. So also here we try to develop a common uniform methodology in order to calculate savings achieved by electric vehicles, so by the fuel switching. And indicative values are available for different types of vehicles like cars, vans, buses, and trucks, and different options of fuel, so not only just pure electric vehicles, but also hybrid options. Last of our priority actions for the first round is public lighting, where we mostly focused on road lighting. The methodologies presented offer 2 options: a simplified approach for savings calculation, which includes indicative values, and an engineering approach, which is using data from the implemented project itself. Why do we do that? Mostly because feedback was that this is mostly a or in many cases a municipal or an action that municipalities implement, and often data is lacking in order to report the savings achieved by this. So we wanted to offer different calculation approaches depending on the data available, while still making sure that also the simplified approach with indicative values is still very close to reality. Additionally, both methodologies give the possibility to account for lighting control systems. And additionally to our guidance, to make this a little bit more interactive, in the last few months we have prepared and developed a training module, which is online since end of October of this year. It provides online calculation templates for all of the methodologies I just introduced to you. So all the indicative calculation values we have prepared are included here, as well as data on costs and the estimation of greenhouse gas emission reduction. You can find the link in my presentation, and I think somebody will also post it in the chat. And in order to demonstrate you what you can see there, I will now jump directly to the presentation, to the platform. So basically, I think I have to log in again. Yes. When entering the page, you first end up in our forum, which is great for exchange between experts, policy officers, people interested in a specific measure, and also the consortium in case you have questions. And also maybe a short introduction, there's also the knowledge and support facility, where the results from our previous meetings, for example, our dialogue group meetings, where PAs and methodologies are presented in a more concise way, are discussed. So all our reports or all our meeting minutes and presentations so far you can find here. And then to the training module. When logging in and clicking on training, you find the 8 methodologies we have prepared. From now, I will, for example, demonstrate you this with building automation and control systems. So clicking on calculate. The top area once again gives a short introduction on the methodology and shows the formulas used for the calculation. You will also find a link to the practical guidance here. So in every calculation template, you can always open the report itself or download this as an empty Excel template in case you prefer to work offline. But for now, we will stay online. First information is about indicative values. Those indicative values are either EU-wide or national values and are used for calculating calculating both primary energy savings and greenhouse gas emissions. When selecting EU values, we have prepared values for you in case you want to use national values, which of course is always advisable. A little table pops up where you can enter the emission factor and funnel to primary energy conversion factor for your country. Then let's, for this methodology, choose a region, let's say West. Then we are in a residential building, a single family home, and we will focus on cooling. And our back target, so how good is the system that we will implement, is A. Then, in order to be able to calculate both the final energy to primary energy conversion as well as the greenhouse gas emissions, of course, we need to know the energy carriers before implementation and after. But since we are at cooling, this will be, for now, 100% electric. Then we have two calculation boxes, which might be a little bit confusing in the beginning. The indicative calculation values are the values that we have proposed in the project. So those are EU-wide values based on statistical data, and those will be the values you also find in the report itself. So here everything except square meters of the building are already filled out. Let's say it's 100 square feet single family home, square meter. And at the same time, if you want to use your own values, it is possible to fill out national values with different approaches for, or different values used for every term used in the, used in the calculation. After filling in the information, I will for now leave this empty. You click on calculate. And after waiting a very short time, that's usually not that long, you'd first see again the information on the formula and information on the data you've entered. And below there you see the savings achieved. So both for Article 3, the total final energy savings, as same for Article 3. Then the effect on primary energy consumption and the greenhouse gas savings achieved by implementing this specific action. Also, the results section features the costs related to the action, so gives information on, in for example, euro per square meter, how much implementing such an action will cost. In the case of bugs, an upgrade to class C or an upgrade to class R. Additionally, if you want to keep this or work offline with those results or include it in some other analysis you've already done, you can download the Excel file, which nope. So I'm going to move it over here. And basically the Excel file is already filled, and if you click on, or if you activate it, it actually also calculates. And so data is filled in and you get the same results that you would also get from the platform itself. By the way, in case, as we are still collecting feedback for now, in case you want to check this out and give us some feedback, then we are very happy about this. And maybe one last feature, all the calculations you do are saved. Not then only visible to you, but not everyone. But you can go back to them in case you are trying different options. And I think that's it from my side for now. So in case there are any open questions, I think we will discuss them at the end of the webinar. Thank you.
Thanks, Elizabeth. It was impressive. Really great demonstration of the tool. Thanks a lot. Indeed, there are some questions addressed to you already, but let's keep them for after the final presentation of today. Presentation by Conor Malloy from the Authentic Energy Management Services in Ireland. That's a company that helps businesses to save energy and emissions, specialized in sustainable transport and logistics programs. So Conor is perfectly casted to take us along a standardized savings perspective from the industry. So Conor, please, happy to have you in the panel today.
Excellent. Thank you very much indeed. You know, delighted to be here, and I have to say I've learned a lot from the previous speakers. So yeah, very interesting. Delighted to see modal shift being mentioned as one of the future questions the project is going to try and answer, modal shift in freight. But as Dieter said, yeah, I've been working in the industry, so I'm very much a commercial operator. I'm not a policymaker. Don't get involved in it. Very much out in the field. CMVP stands for Certified Measurement and Verification Professionals. So if you like, I make a living some of the time from doing the metered savings, the M&V that's needed for some of those jobs. So that's kind of perspective where I'm coming from. The last 17 years, I've been helping fleets save fuel. That's what I do. Obviously, in recent years, we've been doing more and more electrification. I think just a brief mention for the Global Logistics Emissions Council, the GLEC. We got invited, or I got invited onto that because of work we did under Article 7 and the EOS in measuring and verifying emission savings and fuel cost savings, effectively energy efficiency under the EOS program here, and that program is ongoing. I'm not going to talk about it today, but that's effectively, you know, if you like, doing the day job. That's how we got into that. Various points there about experience and different aspects. The Association of Energy Engineers is worth shouting out, but again, I'm not going to dwell on that too much. Let's just talk a little bit about the challenge. So I was asked to give an industry perspective on the challenge of using standardized savings and indicative values. So I'd like to take you back to 2015, if I may. 2015 was the year of Dieselgate in my industry, and you know, it wasn't too much of a surprise, I think, to many of us, most of us that worked in measurement and verification, emissions control, etc. It certainly wasn't news, but it certainly seemed to come as a shock to policymakers and obviously to the law enforcement profession in certain countries. But within Dieselgate, there was intertwined a expose, if you like, or a bringing to prominence of the increasing gap year on year between test data. So here on the left, you know, the test certificate that we give out and a lot of us rely on for savings, and the real world. And these graphics are from the ICCT, the people that did the Dieselgate testing. So they're very much on the side of the good guys, if I can put it that way. And you can see here, 2001, there was a 7% gap, 2005, a 13% gap, 2009, a 17% gap, and 2013, a 30% gap. And bear in mind, if you like, the blue color is the test and the brown color is the on-road, the real world results. So it's just kind of important just to ground our conversations. There is a real need, as I'll come back to, for streamSAVE and for deemed savings and model savings, etc. But you know, it's just important to ground things as well and where we're at. So where we finished with the NEDC, which is now gone, the new European drive cycle, it's now become the WLTP, was close on a 40% gap between what was modeled or tested and the real world. Okay, and obviously for someone like me who's saying to a customer, look, you need to switch from vehicle A to vehicle B to save fuel, and they sort of look at what it says in the brochure, it says on the tin, as we say here, you know, it's significantly different, and that makes it very difficult for people to have confidence in their investment decisions. So just a couple of points about this. You know, we need, if we're going to persuade investors, if we're going to persuade fleet managers and their chief financial officers to invest in electromobility, and there's many aspects to it beyond just electric cars. We know it's difficult. Real world, independent measurement and verification of savings are rare. You know, I do a little bit of work. I do operate some programs, I design and deliver them, but realistically, it's a drop in the ocean. Supplier references are also out there. They're useful, but they're not enough. They're, you know, you don't, if you like, they come with a certain you know, from a certain source. They're just the supplier's preferred, if you like, reference stories. So there's always a certain amount of selectivity in them. You also have the big question, how were the savings calculated? Was it greenwash or was it IPMVP? And the IPMVP stands for the International Performance Measurement and Verification Protocol. You can see why they gave that one an acronym. And you know, that's the standard that I work to, and many of my colleagues, and I can see a couple of them on the call actually, would work to in terms of calculating energy savings and energy efficiency savings in particular. But what was used? Often we're not told, we don't know how the calculations are done, were they done by someone independent, etc. It's not there. So we, the industry, and the policymakers need a shorthand. We need a reference upon which to base decisions, investment decisions for my customers, policy decisions for many of the people on the call. We need some form of shorthand. Now you may say, well, that's what streamSAVE is all about. It is, and to sort of as a vote of confidence in streamSAVE, I'll just share with you an example from 2019, which is an industry example. And it's called the GLEC framework, as in the Global Logistics Emissions Council I mentioned earlier. And I mentioned, you know, we were invited into this group because of the work we did under EOS. So, you know, with primary data, I might add, because one of the challenges in the industry is the lack of data. So if you're trying to move freight and you're trying to measure your emissions or the difference between option A and option B, it's very difficult to do it, right? There's a big gap, and you can't do, as I think Anne said earlier, you know, it's not possible cost effectively to IPMVP each and every project or each and every journey or each and every leg of every journey. It just doesn't make sense. We need smarter ways of doing it. So if you like, the GLEC fills the data gap in terms of assumptions, ways to calculate, etc., for moving freight by different modes. And it doesn't answer the full question, which I'm sure streamSAVE will, but it does allow us to figure out what the greenhouse gas emissions are. It does allow us to manage performance, and it does allow us to evaluate the impact of different measures and changes and actions. So, and from the point of view of the large corporates that use it, it allows you to track progress towards climate goals. So if you like, the industry's view would be there is a need for these deemed savings, for want of a better description. They're not the be all and end all. There are underlying aspects that we need to be aware of, but you know, there is a need and it needs to be filled. And you can see here the freight industry globally coming together to create its own solution, which will now shortly become ISO 14083. So just to summarize, because I was asked to talk very briefly, I hope I've kept it nice and short. You know, the uncertainty that's around the savings between electromobility and fossil fuel, etc. And believe it or not, it's still out there. It leads to investment hesitancy. It delays action, and the need for climate action is urgent. You know, we need these investment decisions to speed up. So, you know, streamSAVE does have applications within the wider commercial world as much as it does within the policy-making world. And, you know, we need to accelerate adoption of electromobility in all its many forms. So I noticed the modal shift, and you'll see a picture of a truck on my front page here and on my last closing slide here in a second. And, you know, one of the biggest changes I've seen is the movement not from trucks to rail, because that isn't happening, to be frank. What is happening is the movement from vans to cargo bikes. And cargo bikes have they don't tell us how much energy they're using. So it's a whole new ball game. How are we going to measure and report and measure and verify those savings? So, you know, it's not just cars, trucks, vans, and buses. There's also 2-, 3-, and 4-wheelers out there that need to be included. So I think, you know, to finish up, I think streamSAVE does offers this common basis for decisions. It stops a lot of arguments by having a common European platform. So it certainly gets a vote from me. And I think for those who are interested in doing a deeper dive on this topic around how to calculate in transport, what all of the uncertainties are, the Association of Energy Engineers has a training course coming up on this in January in European time. So this is Central European time for a change, not American time. And that's coming up in January for anyone's interested in doing a deeper dive on this. But for us, yeah, we see a need for streamSAVE. We look forward to the debate and the questions coming in now. And I know I have certainly got some questions myself that I'd like to put to some of the panels. So back to you, Dieter, on that. Thank you.
And then now it's my pleasure to introduce you to Elena Allegrini from ENEA, the Italian Energy Agency, where Elena has been working as a researcher for the Department of Energy Efficiency since 2018. Her activity is addressed to technical consulting on Italian supporting schemes for buildings, training courses for professionals, and dissemination through technical guidance documents. Elena, I'm looking forward to your presentation.
So, thank you, first of all. Before starting the presentation, I really want to thank you for your time, for your invitation, and for this kind of opportunity. So, the title of my presentation is the Standardized Calculation Methods, the Italian Experience with the Tax Relief Mechanism. So, here is the table of contents. I will talk about some examples of alternative measures in terms of supporting schemes in Italy. Then I will talk about the annual report on energy efficiency, focusing the attentions on the energy savings we reached every year. And then in the end, I will talk about the importance and the added value of standardized methods. So, in order to improve the energy efficiency in Europe, the Article 7 of the Energy Efficiency Directive requires each member state to achieve yearly energy savings through two different options, the energy efficiency obligation schemes or the alternative measures. Financial schemes and fiscal incentives belong to the latter category, to alternative measures. So if we want to focus the attention on the supporting schemes in terms of tax relief for the energy efficiency actions for the building renovation in my country, in Italy, here is the list of the most important incentives in terms of building renovation. We have the so-called bonus casa, we have the so-called eco bonus, then we have the so-called bonus facciate, and in the end, super bonus. In the case of bonus casa, the tax relief is equal to 50%. Then, if we consider the eco bonus, the tax relief varies between a minimum value of 50% up to 85%. This variation is due and depends on the type of project and action we develop. Then we have the bonus facciate, where the tax relief is equal to 90%. Then, in the end, we have the super bonus with 110% of tax relief. If we want to focus the attention on the building automation, this kind of action can access several incentives, namely bonus casa, eco bonus, and super bonus. So here, this slide shows the list of complete intervention and action for every single mechanism. If you want to gather further information and details, please visit our website by clicking on the link on the top of the slide. So, for the monitoring activity, we need to collect data related to the energy savings. So if we focus the attention on bonus casa, the primary energy savings are calculated by standardized method, and these are the data we use for the monitoring activity. Then, if we focus the attention on the eco bonus, the primary energy savings are calculated by professionals, namely engineers or architects, according to the national regulations, or by standardized methods. The latter, the standardized methods, can be used only for some specific cases. Then, if we focus the attention on bonus facciate or super bonus, in both cases, the primary energy savings are always calculated by professionals, engineers or architects, according to the national regulations. Here is an example on how we calculate the primary energy savings using standardized methods in the case of building automation. We begin with the energy saving data according to the table 3 given by the Italian Authority for Electricity and Gas. So we have the first table on the top where we have the energy saving in terms of tau per 10⁻³ divided on the two main services, heating and heating plus domestic hot water. The values vary depending on the climatic zone from A up to F, where A represents the hottest area, while F the coldest one. Of course, we're talking about Italy. Then we calculate the energy saving in kilowatt-hour using the second table. Once we have this information, we move to the calculation of the building energy requirement for a specific surface, 82 square meters, and considering an initial value for the efficiency for the production equal to 0,80, and then a final one equal to 0.945. These values are always given by the Italian Authority for Electricity and Gas. Then, considering the exact specific area of the flat or the building, we calculate the building energy requirement in terms of kilowatt-hour per year. And then, passing through the primary energy conversion factor, we calculate the building energy requirement in terms of primary energy, the so-called BERPE. So once the building energy requirement in terms of primary energy is given, we can calculate the energy savings, kilowatt-hour per year, with the specific intervention of building automation. In order to do this goal, we need to calculate, to use some parameters related to the class for the building automation. These are the values given in the bottom of the slide with this table. So depending on the class of the building automation and depending on the service, heating or domestic hot water, we use different parameters. Just a focus on this table, where the class D represent the traditional solution, which means no no automation at all. Class C represents the standards and the reference. Then we have class B, which represents the advanced solution, and then class A, which is the best one, the most efficient solutions for the building automation. Here is another example for eco-bonus. So as we said for the eco-bonus, the primary energy savings can be calculated by professionals or by standardized methods. In order to do that, our department, our group, developed two apps, one for the shading systems and the other one for the external blinds. These apps can be downloaded on our website. They are totally free and can be used directly by the final customer, by the final user. So by just giving some information, such as the thermal plant or the region, we calculate, the end user calculates the primary energy saving, which is one of the parameters we need to access the benefit. As I said, every year our department, the National Agency for Energy Efficiency, publishes the annual report concerning the total actions in terms of renovation projects and the targets we achieved in the previous year, with a specific focus on fiscal incentives and building renovation. So, for example, the annual report 2021 concerned the goals and results in 2020. To gather further information, you can visit our website by clicking on the link on the bottom of the slide. So here's the table concerning the data for the yearly energy saving according to the Article 7 of the Energy Efficiency Directive in terms of cumulative data. So in the table you can see all the measures, so the energy efficiency obligation scheme and the list of alternative measures. So we focused attention on the alternative measures number 2, which is related to the fiscal incentives. So the so-called bonus casa, eco bonus, bonus facciate, and super bonus. So it can be easily seen that 10,396 of the total value for the cumulative data come from the alternative measures number 2, so from fiscal incentive, which means that more than 44% of the total energy saving is reached by fiscal incentives. Then, if we compare this data with the minimum cumulative energy saving according to Article 7, they represent more than 40% of the yearly energy saving. If we consider all the measures, energy efficiency obligation schemes and alternative measures, they together represent the 91% of the target according to the Article 7 of the Energy Efficiency Directive in the period between 2014-2020. Then another interesting table, the yearly energy saving megaton per year from fiscal incentives in building renovation. So if we consider 2020, so the previous year, we have a value equal to 0,370. If we focus the attention on the contribution of every single mechanism, bonus casa represents more than 66%. Then we have the eco bonus with more than 30%. Then in the last positions, we have bonus facciate and super bonus, which represent less than 1%. Yes, this is a small amount of percentage, but we have to keep in mind that bonus facciate and super bonus were one of the most important incentives, but they started last year, so in 2020. So in the end, we want to focus the attention on the importance and added value of standardized methods in terms related with the alternative measures. Standardized methods represent a key role in the calculation of the energy saving, and especially for bonus casa. And this is fundamental because bonus casa represent almost 60–70% of the energy saving in 2020. Standardized methods play a key role in the evaluation of the targets according to the Article 7 of the Energy Efficiency Directive, if we focus the attention on alternative measures. And of course, we are talking about something which is standardized, so a procedure very clear, very efficient, that help us to develop tools to easily calculate the amount of energy saving, as we did, for example, for the eco bonus, where the calculation can be led directly by the end user. So this was the last slide. So thank you for your attention. Thank you for your time. Thank you.